Hi, this is Mr. Hodgen. This is the Algebra 2 Semester 2 final exam review. I am going to go through each one of these questions and give a little bit of information as well as the right answer. Feel free to go to the description and you can jump to any question on this video really quickly. So for the first one, we have a graph of a polynomial. We can see that we have three factors here. So because there's three factors listed here, I know it's going to be a cubic function, and you can see the shape of the function is cubic. It's good to know that a positive, I'll do it this way, a positive cubic function will start low and end high. So end behavior on the negative side is negative, the end behavior on the positive side is positive, and it's the reflection for a negative. Okay. So right away, I can already tell, since this is a positive, there's no negative in front, that the shape must look like this. So that's going to eliminate both A and, looks like, yeah, C, because those are both reflected and those are negative coefficients. So we're looking at B or D. So the second thing is just solve these factors. So you want to know, where do these equal 0? So where does x minus 1 equal 0? Where does x plus 1 equal 0? All right, that'll give us the zeros, or also called the roots or the solutions. So we're looking for the polynomial that goes through x equals 1, x equals negative 1, and x equals 4. Right. Just scroll down and check the first one, and we're looking to see, do these go through the x-axis at those points? So we have negative 1, positive 1, and positive 4, so B looks like our solution. If we look at the other possible answer that we had, it goes through negative 4, not positive 4. So be careful not to just take this number and think that's the intercept. You have to set it equal to 0 and then do the algebra to solve for the 0. Okay. All right, let's go on to number 2. All right, very similar question. This is still, you can see, a cubic equation, right? It has the same shape as we had over here, but there's only two x-intercepts, right? So it's kind of confusing. But just remember that when the function hits the x-axis but does not go through but kind of bounces off, that's called a double root. So because of that, we're going to have x plus 1 listed twice. Sorry, x minus 1. X minus 1 listed twice. And then from this x minus 2, I'll have x plus 2. There we go. So it's very important that we do have, since it's the shape of a cubic function, we do have three factors. Right? We have to have three x's to make that cubic shape. So that looks like it's answer D. Let's go down to number 3. Which of the following is true? So give that a read for a second. So we probably want to go ahead and factor this and find out what the other roots are. We already have 1, which is positive 6, but if we factor this, what two numbers multiply to negative 18, add to negative 3, and we'll get x minus 3, or x minus 6, and x plus 3. Right, so all together, looks like we have another instance of a double root, right? We have 2 of the x minus 6's. So that's a double root, so it's going to look something like this, right? And the fancy word when I have a double root geometrically is that it's tangent, right? So think double root and tangent as being the same way of describing the same thing. So it's going to pass through, looks like, at negative 3, right? And it's going to be tangent at 1 point, which is 6. So it passes through the x-axis once and is tangent once. Okay, if you want a picture, it'll look like this. So pass through negative 3, and then at 6, it will be tangent. This is negative 3 over here, passes through, and then is tangent with a double root. So that's B. Right, which is not a factor. So we can do this a number of ways, but synthetic division is probably the fastest. Okay, so using synthetic division, let's see here, and we want a remainder of 0. Well, not a factor, so we're going to say not equal to 0. We're looking for do synthetic division, and we don't want to get 0. So to test this as a factor, just like on number 1, we're actually going to test the number as if we solved this equal to 0. So x equals 1, x minus 1 equals 0, give you x equals 1. So we're going to try synthetic division with the number 1 first. And if that doesn't work, we try -1, and then 2, and then -2. Look for something that gives us a non-zero answer. So our factors, our coefficients are going to be 1, -2, -7, +8, and then +12. So 1, -2, -7, +8, and +12. Okay, and just bring down the first number, and we are testing right now number 1. So 1 times 1 is just 1, and then add it up. -2 plus 1 is -1. 1 times -1 is -1. So we have, add these up, we get -8. And we have 1 times -8 is -8. Add those up, you get 0. And then 1 times 0 is 0. Add those up, and we get 12. So we actually got our non-zero answer, right? This is our remainder here. Off the first one. So I know that this is going to be not a root, okay, what that means graphically, algebraically, but, and I guess we can assume all these others must be roots. If we wanted to check them, we could, just to make sure. Let's go page 2. Which is a factor, so we have to do some factoring here. We should go ahead and try maybe some factor by grouping first. That's usually one of the faster ways to factor if it works. So you factor the first two for GCF and the last two factors for GCF. So factors in common with these two would be they both have an x squared. So we can factor that out. And what do these both have in common? A 2x and a -3 really have nothing in common other than the one number that's always in common all the time, which is +1. So if there's no number that works, always try +1. Okay, and here is a catch about this method is that both of these have to be the same. And both of the factors left over must be the same. So if you factor out an x squared from the first term, you're left with 2x. Factor out an x squared from here, you're left with just -1. And then you can see, and we're left with 2x minus 3. So unfortunately, the factor by grouping did not work because these do not come out to be the same. So we're just going to have to do what we did on the last problem and do synthetic division. Okay, so we can test x equals 1, x equals, let's see here, 3. Test a few of these just to see what works. So we're going to try 1 first. So we'll have 2, -1, 2, and -3 as our coefficients. Bring down the first number, which is actually 2. So 2 times 1 would be 2. -1 plus 2 is 1. 1 times 1 is 1. 2 plus 1 is 3. And 1 times 3 is 3. And 3 plus, -3 is 0. So we got lucky. Both of these at the first one we tried actually works. So we get a remainder of 0, so that's how I know that yes, 1 is a factor. Notice how on the last problem, let's take a look at it again, that it was asking which one is not a factor, so we're looking for which one was not giving us a remainder of 0. So the same question worded differently and without too much hassle, get an answer of A. Now, if we got something other than 0, we would just take this out and put a 3 here, erase these numbers, and just try again with that until we did get an answer of 0. Chances are it will not be this the first choice each time. All right, so let's look at number 6, the quotient when p of x equals x to the third minus 3x squared minus 16x minus 12 is divided by x minus 1. We get this quotient, okay, did the long division for us. Which of the following are not, okay, it's always good to notice, not necessarily true. So because we divided it and we got this leftover remainder, we got a remainder of 30 if we did this synthetically, right? And when you do the long division or synthetic division and it doesn't come out even, that tells you a few things. It doesn't go in even. So for sure, C is not going to be an answer because x minus 1 did not go in evenly. We got this fraction on the end, so that can't be it, right? We substitute 1 in for x, p of x results in negative 30. This is true because the negative 30 they're talking about is right here. That's the remainder we got. So that's definitely true. So that can't be it, right? And we're left with these two. Is p of 1 not equal to 0? Well, if it was a solution, yeah, p of 1 would be equal to 0. So that can't be it. So it leaves us with negative 1 is not a 0 for p of x. Notice how we didn't test negative 1 by dividing by x minus 1. That's technically testing x equals positive 1, right? Back to the prior two problems. So we do not know about anything about negative 1 being 0 or not. All we know about is what happened with positive 1, right? This is positive 1, this is x equals 1, and this is x equals 1. All right, let's look at number 7. And we can do what is the fractional part of the quotient. So we just need to do a little bit of long division to find out what we get. And right away I can tell we're talking about the fractional part, so our answer should be a fraction. So we're not going to have A or D. Another way of looking at that is that, look at the one before, you'll notice that if we divide it by x minus 1, the fractional part of the quotient right here has an x minus 1 on the bottom. Those will always match, what you're dividing with, and this part on the bottom. So we have a 2x plus 3 on the bottom, so it makes sense the fractional part of our quotient should have that on the bottom as well. So we just need to do the work here and see what we get. We can do it long division method on this one. Just have to write it out. Okay. And let's see here. 2x times what is the 6x to the third? All right, you'll probably come up with 3x squared. So we have 3x squared times 2x gives us the 6x to the third. 3x squared times 3 gives us the 9x squared. And we go ahead and subtract that. So we have 6 minus 6 is 0. 5 minus 9 gives me negative 4x squared. And then bring down the 2x. And then go ahead and do 2x times negative 4x squared. Well, 2 times what is negative 4x? So we're going to do minus 2x. Right, so we'll have negative 4x squared. And we'll have negative 6x. And now remember, you are subtracting here, so it's a little weird. You have to do negative 4 minus a negative 4, which gives us 0. And we have to do 2 minus a negative 6, which gives you 8x. Bring down 7. And do one more go through here. So 2x times what is 8x? We'll get 4. You might notice what we have here as our partial quotient is what d is. So multiply this out, we'll have 8x and then 12. Right? And again, we're subtracting. 8 minus 8 is 0. 7 minus 12 is negative 5. So our fraction part of the answer, this is our remainder, right? It's going to be minus 5 over our divisor, 2x plus 3. So this would be our answer, which is B. All right, let's look at some least common denominator of an expression. So this is just a factoring exercise, more of Algebra 1 review. So factor the bottom. What multiplies to negative 4 and adds to positive 3? So you should probably come up with 4 and 1, right, with probably positive 4 and negative 1, right? That'll give us positive 3 if we subtract them, and negative 4 if we multiply. And then over here we'll have, let's see, factor x squared minus 16, which is simply x plus 4 and x minus 4. So let's see what they have in common here. They have this in common. So in order to get an LCM, or least common denominator, LCD here, we'll need to put on each fraction what the other one is missing. So for instance, this fraction does not have an x minus 4. So, right, and this one does not have an x minus 1. So now you can see that they're all in common, so this would be our LCD, which is choice C, right there. Let's go to number 9. Right, make that a little smaller. So let's go ahead and factor this, do some more factoring, and we can see what kind of asymptotes or graphical missing information we have, or the holes. So factoring the top, we have x multiplies to 18, adds a negative 9. Right? We'll end up with 6 and 3, both negative. And then the bottom, probably have one of them match. Let's see, multiplies to negative 12 and adds to 1. So we'll have, I think, yeah, negative 3 and positive 4 here. So we can see that we have a cancellation here, and because it cancels top and bottom, same factor, right? Cancels out. That's how you get the whole, okay? And since this is a minus 3, the whole is actually at positive 3. So this is going to be true. And there's nothing else canceling out, so that means this other whole at negative 4 is going to be false. So now we can look at the vertical asymptote. Where does it occur? And for the vertical asymptote, you're looking at the denominator. So this is x plus 4, so the vertical asymptote is going to happen at negative 4. So this is true, and this would be false. Just in case you're curious, here's a graph of this, and you can see that there's a vertical asymptote at the negative 4, right? And then if we approach to, let's see, 3, close to x equals 3 here, we should get an undefined. Where'd it go? There it is. So there's our hole. For number 10, we need to find out which is the right equation here for this graph. So we can tell that the graph is moved to the left, right? At negative 4, we can see the asymptote. So that lets me know that our denominator here must be x plus 4. So we're looking at one of those two. So A or B are out, right? But we need to distinguish which one it is. And we can also see just by looking at the equations here, since these degrees are the same, that the horizontal asymptote is -2. So we can see that as well. Horizontal asymptote is -2. Okay, the question is, which one is it between here? So we'll have to do some long division to find out. So let's just divide these both and see what we end up with. So -2x minus 9, right? And we'll have, let's see here, -2, and then we'll have minus 8. So negative, remember this is minus, negative, minus, and negative, positive, so we get 0. Negative minus negative is positive, so we'll get -1. So we'll get minus 1 over x plus 4 here. Right? And if we did the same thing for D, right, it'd be a very similar answer here. We'll have x plus 4, and then -2x minus 7, and we'll have, let's see here, a very similar answer. -2x, and this time will be -8, same thing, but we'll end up with a positive 1. So this will come out to be plus 1 over x plus 4. So the difference between these two is that we have a minus and this one's a plus. So we have to go back to kind of like we did with the cubics earlier and knowing which is positive, which is negative. So for a graph that has a negative rational, that's going to look like this. It's going to have it on the first and second and fourth quadrant. We're going to have the graphing. When it's positive, by default, it's going to have the first and third quadrants. So that lets me know that our answer is right here, the plus 1 plus x plus 4, which is D.